Good morning, everyone. My name is Xiongtao. I come from College of Computer and Engineering, Xi'an University of Post and Telecommunications. The subject of my report is Chinese medical question answer matching, based on interactive sentence representation learning. Question and answer machine is a subtest of the automatic question and answer system, which is applied in Chinese medical to answer practice questions automatically. There are not many studies on automatic answer question in Chinese medical, because it's difficult to obtain applicable data for experiments. Now more and more online health websites in China have accumulated a large amount of question and answer data. This data allow us to study the application of question and answer in Chinese. My report is about the Chinese medical question answer matching. I will report from the following four aspects. Part one, introduction. In this part, I will talk about some previous work in medical question and answer matching. Part two, method. In this part, I will say about my ideas in Chinese medical question and answer matching. Part three, experiments. In this part, is my experiments part. Part four, conclusion. In this part, is about my summary. In this part, I will elaborate from the following four sections: Chinese medical background, our study objective, about the Chinese medical question answer matching previous works, and a better solution. There are many online medical websites in China. For example, 寻医问药、左耳医生、微医、好大夫在线。On these websites, a large number of the users ask a sick question every day, and professional doctors answer this question. Of course, this provides data of these users if confidential, which is not visible to ordinary users. We get deserves questions and related answers on these websites. For example, the users on the left asked a question about a cough. The cough was severe and itch, with a small amount of right volume. On the right is the doctor's answer, which consists of the two parts: question analysis and advice. If we assume that the doctor's answer are correct, then we have an applicable question and answer dataset. Our study will begin here. For a practice question, the question answer matching is to select the most matching relevant answer from the candidate answer set. Relevant answer refer to doctor's answers. Irrelevant answers refer to worry answers. We can see that the questions posed by the users here are very variable and are not logical. Therefore, this work is very challenging. I will briefly introduce the recent research works on the application of deep learning technology to question answer matching in general fields and professional medical field. In the general field of question and answer matching, the early methods are many log login rulers information retrieval matching visit. This method only means the Xi'an test information without extracting the deep semantic information of the test. Now, many deep learning methods are applying to question and answer matching. For example, CNN, RNN, LSTM, and addition. However, these methods answer question in the specific medical field needs a special study to wide performance technique. These mixes need a special made dictionary to handle question and answer matching questions and answers. Compared with the general field, there is only a small amount of research work in Chinese medical question answering. Perhaps the special Chinese language structure and the medical expertise completed the problem. Zhang et al. Proposed a multi-scale conclusion neural network model based on cherry-kit embedding to extract the test semantic information. This showed that cherry-kit embedding and multi-scale convolution were more advantageous than statistical rulers methods. Ye et al. Proposed a multi-near composite convolutional network model, which stacks multiple convolutional neural networks together and extracts the characteristics of question and answer from each near. Thus, enrich the information of the ban representation vector. Zhang et al. Proposed a hybrid mode of the CNN and BiGRU neural network for Chinese medical question answer selection. Their mode combines the advantage of the different structure of the two neural networks. Zhang et al. Proposed a method of incorporating addition mechanism into multi-scale convolution networks to focus on the interaction of the question and answers. Their results show that the question answer matching chain process needs to focus on the connection between question and answers. Their results are difficult to meet the application criteria. If better model performance is needed, we have a more complex neural network. In the process of the tree, the BERT neural network can capture more complex semantic information, which is an opportunity. I will talk about our model design and model object function. In our model design, we first designed a BERT summers model. In this model, the summers structure of this model includes two branches, which share weights and parameters. The question and the answers will be represented as vectors of the same list for similarity correlation. In this model, the input is the question and the answer sets of the equal list. This requires us to pre-process the data and cut the data into one 150 words in this. If the thickness is less than 150 words, we need to and zeros to put in it. If the sentence is longer than 150 words, we only use the first 150 words. Then we use position embedding, segment embedding, and token embedding of the sentence squares as inputs to the BERT network, where token is equivalent to Chinese characters. Finally, we use the point BERT network output as a sentence repetition. Then the cosine similarly for conclusion, the connection between question and answer. Compared with a previewed model, a previewed model can extract a deep state sentence representations of question and answer separately, but the semantic correlation between them is equal. So we need interaction between questions and answers during mod tree. In the BERT networks, direction transformer can vote not only on the each token within the sentence, but also on the relationship between the question and the answers. Therefore, we speed together the tree parts of the two BERT networks. Inspired by Zhang et al., we designed a hybrid model, use the multi-scale CNNS and BERT. In this model, the multi-scale CNNS network uses a series of convolution chaos of different sizes in convolution operation, each of which extracts an grammar feature in sentence. Then, we designed a hybrid model using BiGRU and BERT. Why use BiGRU? First, CNN network is good and means the aesthetic feature of knock position in sentence, but is difficult to extract the older information of Chinese characters in sentence. Second, the RNN can capture secrets information in sentence. However, RNN may have problems with gradient disappearance and gradient explosion during mod tree. And then the GRU network not only solved the problems of the RNN, but also simplifies the LSTM network and improves the mode computing performance. All of our mode object function is matching node function. In this function, there are questions, relevant answers, and irrelevant answers. Their relationship, the greater the similarity between the question and relevant answer, the smaller those value. The greater the similarity between the question and the irrelevant answer, the greater the those value. In this part, I will elaborate from the following four section. These systems used in our model training. Our model measures experiments results and error analysis. The training datasets we used were Vision 1.0 and Vision 2.0 of the Chinese medical question and answer disease. This disease was driven from an online Chinese medical health community, Xi'an, which is provided by real users. VLC 2.0 has roughly twice as much data as Vision 1.0. We use the Turkey query to evaluate performance of our model. It represents the selection of the first key out of 100 answers as an evaluation of our model. In our model, the key value is taken as 1. So the rounder accuracy rate is only 1%. This requires is very structured. Our experiments results are shown in the table. Our model achieves better model performance and important reason for the improvement the performance of the Chinese medical question answer matching model is that we use the interactive BERT network. This also shows that the question and answer matching requires not only the rich sentence characters, but also the relevant information between the question and answer. We present the BERT network using a Chinese medical corp. In the figure, blue is the model performance without preaching, and red is the model performance with preaching. Therefore, a preaching is necessary for Chinese medical tests. How to use the output of a BERT network for question answer matching? There are 3 ways to output the BERT network, and we compare them experimentally from the experiment results. The application of the BERT network is in sentence representation learning needs more abundant and useful features. In error analysis part, the first reason is the even distribution of experiment disease and more complex syntax in the medical field. The second reason is error generated when collection dataset manually. The third reason is a question may correspond to multiple answers, and our model only matches a cell answers, which affect the final performance of our model. In our future work, the first future research direction is that we will try to transform unstructured test data into graph structure, similar to a knowledge map. The data of graph structure is easier for machine to understand, so as to improve the accuracy of our model in answering questions. The second future research direction is to introduce a map of medical knowledge into our model to get question answer matching. The third future research direction is to collect more medical question and answer data set to improve the performance of the model. Last, thank you. I would to extend my sense gratitude to my supervisor, Jungang. From him, instructive advice and useful advice on my this. I'm deeply grateful of him help in the completion of this. I'm also deeply indebted to other review of this paper. Finally, indebted to my friends. Thank you.